let's get started. So let me give you a premise behind this talk. I think we focus a lot on the technology stack itself, the Hadoop stack itself, the parts of the tech stack that Hadoop is, or the ecosystem. And there aren't really or nearly enough talks that goes broad and looks at all the other factors that goes into making a big data platform successful in an organization. So this is an attempt to cover those considerations, okay? So just to introduce myself, my name is Sumeet Singh, and I lead products for Hadoop at Yahoo. I've had a few different roles in my last 4 years at Yahoo. Just a disclaimer that these considerations, these top 10, are my take based on my experiences, and your list could be different based on your business, your situation. But nonetheless, I believe you can benefit from the perspectives we have gathered over the years. Again, just to set context of what Hadoop at Yahoo looks like, what we do with Hadoop, our products and properties, and we have a lot of those, generate a lot of data. Just the audience events would be 150 billion a day. And all that needs an economical place to land for processing, and that's what Hadoop Grid is at Yahoo. Right? We also pull a lot of data from a variety of third-party sources, be it web crawl content or content that we obtain in partnership with other data service providers. All that lands up in a common place, and the idea is that if you have all of organization's data in one place, it becomes a lot easier to do enrichment, drive interesting user experiences, do deduplication, and all kinds of other things. So sharing becomes a good goal for the company, and that's why we're set up like this. And of course, once that data is processed in Hadoop, it's applied back into the business in terms of personalization, in terms of driving, I would say, advertising, such as ad targeting or campaign management. The data itself is served back in many cases, the processed data, right? So there's a lot of value in us bringing all that data on a common platform, and then applying the results from the processing we do on that data back in our business. And of course, you do BI reporting and analytics on top of that processed result. Okay, so that's the overall context of Hadoop at Yahoo. And over the years, since we've been doing Hadoop, it has scaled fairly well for us. And that's the sort of the idea behind the talk is what are the types of considerations that have gone in to take us to this level. If you look at the scale and the use cases along this growth, both in infrastructure as well as the tech stack, has just continued to grow. And we continue to invest in this space for a variety of reasons, which you guys are all familiar with because you're here. So with that, let's jump into what those 10 considerations are that would perhaps go in making a platform like this successful for the business, okay? So obviously, the first consideration is where do you run Hadoop, right? Where do you go, be it public cloud, or do you want to set up an on-premise infrastructure? So we'll look at what those considerations are when you're thinking about where to go. The second in my mind is that unless you've understood your total cost of operations or ownership, it's really hard to make intelligent decisions around investing in infrastructure as well as investing in headcount or for profitability of your business or return on investment in the space. So you get to get a handle, even if it's rough, on the total cost of ownership because it's going to drive a lot of intelligent decisions, okay? Then we get a lot of questions of what type of hardware or configuration do we run? And so it's important to answer that. And how do you think about hardware configuration that you would purchase, let's say, to set up a Hadoop infrastructure or HBase or Storm, whatever the case may be. Network is often not talked about, but it's a huge component in any distributed system. So I want to touch upon network a little bit more than the other topics as to why it's important. And then software stack, of course, is important. So I'm not going to spend a lot of time on the software stack. We'll definitely touch upon how we think about the software stack, okay? Security and account management is a huge area, so it's a sort of a disservice to that area in a talk like this, but I'll touch upon what's important, how you think about that. Data lifecycle management, data movement, BCP, these are all really important considerations in a database operation, so it's important to touch upon those. And then metering, audit, and governance is another area that often gets overlooked, but can actually result in, I would say, a lot of pain and frustration later. And then finally, this big data infrastructure or Hadoop infrastructure has to work with a lot of other external systems. So what are those integration points, and how well does it integrate with other systems? And then finally, there are lots of myths floating around the architectural considerations with Hadoop, so I want to touch upon those, what's really true as far as we see and what's not true. Okay. So let's talk about the first topic, which is where do you go, right? So there are typically two predominant models of deployment. One's on-premise, so you would set up an infrastructure on your own, and when considering an on-premise infrastructure, you could either go on a dedicated cluster where you run a single large app or a very demanding use case, or you have scaled to an extent that the cluster can't take anything else. That model's valid for on-premise, although the dominant model, where you get the economies of scale in both cost and operations, is the multi-tenant hosted model, where you actually bring a lot of projects on the same platform, and Hadoop's built with multi-tenancy. We have built a multi-tenancy in Storm and HOS as well. So multi-tenancy is a basic tenet for hosted cloud service, be it on-premise or public. So these are the two predominant models you would go with on-premise, and often there is sharing of data between these two, right? When it comes to public cloud, I think the most popular one is this hosted compute cluster, where you'll grab a set of instances and run Hadoop on it, right? So it becomes your cluster for the time you have them. Be you have it for 24/7 or only for when your application runs, right? So stuff you would do on Amazon Cloud. If you're not using EMR services, let's say you're just using EC2 Cloud, that's the type of model I'm talking about. And increasingly, we're seeing a lot of purpose-built cloud, public cloud, which is purpose-built for big data, right? And the take here is that there is a much tighter integration between different stock components that you get out of the box when you're using that cloud service. And oftentimes, you get additional value-added service that you would need for database applications. So there's a rise in sort of purpose-built public cloud as well for big data, right? So you choose between these two. And how do you choose between them? I think there is no hard and fast rule, but there are some things you would consider. Cost is almost always important. Like if it gets too expensive to run an on-premise infrastructure, go to cloud, and vice versa, right? And there are certain things that come in play, like fixed cost in setting up your own infrastructure. It favors certain characteristics when it comes to scale and operations versus public cloud. Data is important. Where is data being generated? How is data being moved? Where is it being moved? If it's generated in cloud, probably it's better to process in cloud because data movement is painful. And data has a lot of inertia. So it's important to understand how the data is being moved that you're processing. I think SLA is also exceptionally important. The notion around SLA is directly tied to cost, because the more tighter SLAs you have, the more hardware you're going to throw at it. So balancing that out in public cloud and private cloud have different dynamics, and how you're going to set up SLA. Okay. Tech stack always is important, so you have a lot of control, and when you want to exercise a lot of control, probably it's important to set up an on-premise infrastructure, but also requires you to set up people who can support that infrastructure, right? So security, on the contrary, as people may think, is more important in public cloud. I think it's actually a bigger deal in private cloud, particularly when you're offering hosted multi-tenant service for the company and your data, underlying data is shared. Like I was just in the Hive session before, and there were a lot of talks about who can see my table versus not. And then multi-tenancy, as I said, is always important, but multi-tenancy matters a lot for on-premise infrastructure versus a public cloud infrastructure where the virtual cluster that you have is pretty much yours. There's no one else running on it. Okay, so how do you evaluate these criteria? I think, as I said, quantitatively, you could evaluate cost or benchmark cost in SLAs versus one versus the other, either through trial runs or through theoretical benchmarks. You grab the equivalent set of instances from a public cloud, price them at public pricing. There are various approaches you could quantify which one's better for you. And the other ones are a little more qualitative. And the idea here is that just one criteria could sway you in one direction, and you don't really need to look at all. But I think it's always important to look at a holistic sort of picture around what type of deployment's favorable for your business. And then one way to think about it is that when you have an on-premise infrastructure, it favors scale and utilization. So this step line, the purple step line, is an on-premise infrastructure. And the first time you get started, you have a large fixed cost, and every time you scale that infrastructure up, your cost grows literally vertically for that investment, and then you're unstable without any cost, right? And then again, when you have to scale it up, it goes up. Public cloud actually starts to be probably cheaper when you begin with, and then tiered pricing kicks in, or you could have contractual pricing. But nonetheless, at a certain scale, at a certain set of utilization that you have on your on-premise infrastructure, you will experience a crossover point where your on-premise infrastructure becomes more favorable versus the public cloud when your utilization's low, scale's not there. It's going to favor public cloud, right? And really the key here is that you not just want to look at where you are today, but I think you should model out where you want to be with this infrastructure to give you a true picture for which way you want to go. Okay? So that's on what type of deployment model you want to follow, where do you want to go. The second is TCO. It's, as I said, really important to understand your total cost of ownership. But often this is difficult to do because of the variety of data sources you have to gather the information from. But nonetheless, let's look at the components that you have to think about. And again, I'm biased here for on-premise here. That's what we do. But you could run this for public cloud too. The first is hardware itself. And there are a variety of hardware, not just data nodes, right? There are all kinds of different things, proxies, name node, job trackers. And you have to account for all of that and depreciate it properly to get a run rate, which is a monthly run rate of OpEx and CapEx. If you're setting up a platform, of course, you need people to manage that platform. So you have to account for that. There's a lot of active or recurring cost, particularly power and cooling, that would come in play if you're setting up your data centers. So that can be substantial. Network hardware is a big piece, and we'll touch upon that more. As I said, there'll be a lot of one-time cost, or what I would call as acquisition cost, which you need to account for. There'll be a lot of cost in operations headcount. You need to account for that. And finally, bandwidth, network bandwidth, particularly when you're running multiple data centers. And there will be a lot of data transfers, what we call as on intercolo or regional links. And the idea is, again, to get to a monthly run rate which reflects true OpEx and CapEx cost so that you understand where you are, what you're going to spend. And then, once you have a good grasp on your total cost of ownership, which is your monthly total cost, you want to get to a unit cost. So what are the units in a Hadoop platform? Or you could do this with Storm and HBase, and I'll explain that. The first thing is memory. So in Yarn, which is the scheduler we use, there are two components of memory, two components of compute. One is CPU and one is memory, right? So the containers, the Yarn containers, are allocated a set of memory and a set of CPU resources, which that's where your map and reduce task runs. So you just take the total capacity of memory and CPU cores you have in your infrastructure or want to have in your infrastructure. And then the monthly memory cost and the monthly compute cost, I haven't come to that. We just know our monthly cost. We haven't broken that down into compute and storage, which is the next element. So it depends. I think we could easily take a 60-40, 60 on compute. We're more compute bound. Most clusters are compute bound. and 40 on storage, and then take that 60% of our cost in compute to 30-30 between memory and CPU based on how balanced our workloads are. So that totally depends on the type of average workload you experience on the platform or planning to experience on the platform. But the idea here is that once you know your monthly cost, it's really easy to figure out the unit cost. And of course, bandwidth is slightly different because that's at cluster aggregate, leaving the data center or entering the data center, but that's also easy to calculate and spread it across tenants on the cluster. The other thing you want to take a careful note of is the namespace on the name node, because that's often a challenge as far as scale is concerned, because you might feel constrained with the number of name node objects you could support. I mean, we go as high as 500-600 million objects. Now, these objects are files, directories, and blocks that your name node's managing for a cluster, okay? And then, of course, you want to calculate consumption costs, so you have to measure resources that people are using on your platform. And that's easy to measure in the sense that as jobs run, map or reduce, what you're going to do for compute is that take the tasks, map tasks and reduce tasks that run on the platform, give it a notion of time, how long those tasks ran, sum all the tasks for a particular job. That's what's going to give you the cost for that job when you multiply that with the unit cost you derived earlier. Okay? So it's easy to then allocate costs across jobs. Jobs may belong to a projects may belong to a business unit. You could roll this up arbitrarily and still split your cost at any level you want, be it business units within your organization, be it the tenants you're supporting, be it the use cases, jobs. You could go at task level. Storage is even more straightforward. It depends on what your storage hierarchy is, and you could work with raw storage, or you could work with just data, which is like less 3 times based on DFS replication factor you run your clusters at. Okay. And then bandwidth, as I said, is a little harder because it's an aggregate, but you could spread it evenly among tenants based on their usage or based on their transfer rates in and out of clusters. So that's how you're going to go about understanding your true cost of ownership among different tenants, among jobs, and then you could do it for compute, you could do it for storage, and that'll drive a lot of investment decisions in a much more intelligent fashion. The third thing is around, okay, what sort of hardware configurations is suitable for Hadoop? And the answer is that in any data center, there are only few resources that are in play. We're going to talk about networks separately, but bandwidth is one, which, as I said, is just easy to measure, living in and out of data centers, so it's normally called north to south traffic. And then when it comes to the server themselves, there are 3, right? At least in our case, we buy servers with JBODs or disks, so everything is a SATA drive. And memory and CPU are the other 2 resources in play. So how do you think about configuring that hardware, particularly when it's commodity, is that you could think of it as taking these different resources that are in play for the server and arbitrarily combining them based on what gives you the best price to performance ratio, right? That's what you do. So if you look at, and these can get accumulated over generations. Now, one good thing is that eventually you're going to run multiple configurations because that's what's most optimal from a price performance standpoint. And as you can see, we have accumulated generations of hardware. Some you will laugh at, like 24 gig or 0.5 terabyte drives or disks. But it's evolving, and it's going to evolve, and based on how it's priced and what you acquire it as will drive a lot of your decisions and the performance you get out of it. In terms of thinking about how to mix and match these, I think let the framework handle the heterogeneity in configurations. I mean, for us, it's 10 plus configurations that live on the cluster. Hadoop manages it fine. And then as far as heterogeneous storage is concerned, we don't have it. We have pretty much disks, which are all SATA. But you could have other types of storage, like SSDs and others, and there is support in HDFS for that. And then, in fact, there's another work coming out which allows admins of the clusters to allocate labels, so you can even have specialized hardware for specialized applications. And you can give that specialized hardware in the same cluster access to those specialized applications. GPU is one good example, that you could have GPU nodes in the same cluster, but with labels. You can have applications choose where they want to go. Okay? Then let's talk about network. As I said, it's an often ignored component in the overall consideration. The most important thing for network is something called as a network backplane. So if you're not familiar with this term, the idea of constructing a backplane is that you want to have consistent bandwidth transfer rates between any node to any node within the racks, or whether it's intercluster or intra-cluster transfers, you want to have, again, consistent experience. So a common backplane lets you have that to be the same. And that's the whole idea of constructing a backplane. And then as you can see, we run HBase clusters, Storm clusters, Hadoop clusters. They all sort of share the common backplane. So the idea here is that if you have data transfers between racks of a Hadoop cluster versus racks of Hadoop and HBase cluster or Hadoop and Storm cluster, they experience about the same thing. And the other important thing about having a common backplane is that you can move racks between clusters without actually physically reconfiguring the network. So that flexibility is really important as you scale up. Okay? As I talked about the consistency there. So network could be a bottleneck. And this is just one way it could be a bottleneck. So for example, if you're joining data sets between two clusters, large data sets, network could become a bottleneck easily. Same with between Hadoop clusters and HBase clusters if you're not running HBase on the same cluster, like us today, until it all moves over to Yahoo in production. And same with HBase and Storm for types of use cases we have, as well as Hadoop and Storm, right? So network can be a challenge. What's the typical way you design? So this is a typical data center networking. There's nothing special about it, okay? It's just the picture looks fancy, but there's nothing special. You have racks. You have racks here of servers. Each rack has certain capacity, 20, 40, depends on your case. Each rack is configured with a rack switch on top, or top of rack switch, as it's commonly called. And this architecture is called core distribution and access. It's traditional 3-layer architecture for networks and data centers. We also call it a big switch fabric architecture, or BAS stands for big ass switch. It's the name we've given for the big switch-based network architecture. And this is, again, as I said, nothing special here. Traditionally, this is how backplanes are designed. So you would aggregate all the top of rack switches onto BAS switches, and then there's a common large fabric. And that's remember the consistent transfer rates or bandwidth I talked about? That's what gives you the consistent transfer of bandwidth rate. And then based on the capacity of these switches, you could scale the clusters or racks in the data center on that cluster to that size, right? So let's look at one typical case where, let's say, the rack connectivity to the switch, the servers to the switch is 1 gig. So you have consistent 1 gig from each server into the top of rack. And there's a 2-to-1 oversubscription. So oversubscription is just a fancy word for saying, what if everybody was sending traffic at the same time? What's the max you could get? So that's the worst case performance or bandwidth that you could get. Okay, so oversubscription can be reduced or increased. It's a factor of cost and the type of performance you want in your network. And in this case, let's say you get 10 gig as the uplink, and with that fabric on top, you get 80 gigs of backplane bandwidth. Okay? That's how you think about it. And in a typical model, this backplane can easily scale to about 16,000 servers. Okay? Now, I don't think we can have a cluster which is 16,000 servers big, and you could. It depends. Some clusters max out at 2,000 servers, some clusters max out at 5,000. There are a variety of factors that come in play, but an architecture like this can easily take you to 16,000, that's proven. Okay, so what is the issue with this architecture? And there's no issue. The real issue is dollar per server cost that you are willing to spend to connect to the network. And that's what you want to drive down. The other thing you want to drive down is latency. And then the third thing you want to drive down is sort of bandwidth, like you want to drive that up, but keep the cost down, right? So another architecture, and by the way, you could make this redundant, or you could leave it as a single point of failure. It's okay, because Hadoop is rack aware, and you only run L3 protocol here, because again, each server in Hadoop has an IP address, right? So you can just use routing. You don't have to do spanning tree. Because that we all know can be painful. A new architecture, which actually is a very old architecture called CLOS from Classical Circuit Switch Telecom, is becoming popular. And the reason why it's becoming popular is because it's addressing both of those issues that I just talked about, the cost, as well as moving the bandwidth up. So what you do is actually you get rid of the fabric layer, the two layers on top that I talked about, and replace it with a leaf and spine type architecture. So the spine is sort of serving that fabric layer function, and the leaves are directly connected to top of rack switch, and the leaves and spines are always in 1:2 ratio, because you need equal number of link down as well as to the spine. And in this architecture, what you do is you create sort of a virtual chassis, and then the number of virtual chassis drives the scale of these racks and oversubscription. So if you want to drive down oversubscription, you make more virtual chassis, which will cost you more money. The other interesting thing about here is that you don't need to rely on big switches anymore. You can take the same configuration that you have for top of rack and construct your leaves and spines with the same switches. Right, so you don't really need big-ass switches anymore. And then in this case, you could afford a higher level of oversubscription, because if it's 10 gig, which I'm saying it's 10, because so each server's uplink to the rack switch is 10 gig. So let's say each rack has 48 servers. You have 48 10 gig ports on your top of rack switch, and the uplink is 4 40 gig ports. And then based on that, you could then drive the bandwidth in the virtual chassis, so the main switching bandwidth or backplane bandwidth, and you can scale that, as I said, by adding more virtual chassis. You could go up to 160 Gbps. This architecture easily supports over 20,000 servers in a single backplane. And so that's as many nodes as you can have in a single cluster, or construct multiple clusters in the same backplane. Okay. And again, you can leave the top of rack switch as a single point of failure. A lot of people obsess about it. You can spend money on 2 switches, but I think it's fine. Even if a rack goes out, HDFS can handle it. The other interesting note here is what Facebook's doing with Open Compute Project, and I think that's going to drive a new era in sort of networking, where networking, pretty much the last component in a data center moves to commodity. So this is interesting. I mean, we haven't had any experience, but just so you follow the developments, I think this is an interesting take on network. Software stack, of course, that's what we talk about. So this is the stack we've built or assembled over the years. This is where we are today in different versions in Apache open source. And then I think the best way to think about software is to think of the file system in Yarn as sort of the common minimum, right? And then you could just build a stack on top of it without really changing that underneath sort of the layers here, which is more difficult to stabilize. And then you could have a bunch of stuff, in flight or semi-production, non-platformized, or in one-off cases. And as these use cases drive adoption of these technologies, you move them over to the platform stack, right? So that's how at least we think about it. It's better to obsess with the use cases, because you just can't keep up with the development of number of projects in the Apache open source. It's really hard. Security, as I said, is important, and Hadoop has really good support. So Hadoop has standardized on Kerberos. You could use LDAP for all your user and ID management, and then SAML for single sign-on, and then, of course, Kerberos can talk to anything else. And there are different facilities in Kerberos. So LDAP can drive your groups and net groups through roles. The RPC, if you need Hadoop RPC direct, so it has support for our GSS API, Generic Security Service API. And then all the UIs, all the web UIs support Spanego. So the basic idea here is that you can solve all your ID and security challenges with Hadoop. And if you were to peel it a little bit more, I'm not going to go deep into it, but Kerberos supports realms, so you can separate out realms for production versus corporate. You could create multiple realms, whichever way you want. And I said single SAML, some of your traditional stuff, security stuff that you have, as long as it has support for SAML, can be the ID provider, so you could just rely on that. And then create as many separation as you want, and that all will still work well with Hadoop because the whole stack there is standardized on Kerberos and token flows. So the ticket granting server of Kerberos can pass on tokens. Tokens can be passed on for different types of use cases as delegation tokens, and there are other sort of details around it, which I'm not going to get to. The core idea here is that security in Hadoop is not rigid, but yet it's fairly secure. And then data lifecycle management, as I said, is also important. Again, whatever way you decide to move your data or manage your data, govern your data, one of the things you have to think about is these 4 stages of data lifecycle management, starting from acquisition from sources to replication of that data for a variety of purposes, one being BCP. Retention, again, you cannot retain data forever, particularly when you're running at scale. So you need to set policy-based expiration or deletion of data. And then the stuff that you need to archive for either regulatory purposes. By the way, all that security stuff and this stuff is SOX compliant, so there aren't really any issues in sort of thinking about it this way from a compliance standpoint. So you could have an archival system then if you really need to store your data, archive your data for longer periods of time, which you don't want to keep on HDFS, okay? Let's think of a classical sort of setup where data lifecycle management can work really well for a variety of purposes. So acquisition happens, so data is acquired onto Hadoop clusters as a feed, okay? And then that feed represents a data set. That data set could be registered in HCalLog as an external table. And the reason why you want to do that is that you have control over all the data, and all the data works with a schema, or DB, which is the namespace, table, and partition level abstractions. So you have a lot of control over a lot of visibility into what's in HDFS. At the same time, the various tools of the Hadoop ecosystem can interoperate on the same data set. You don't have to encode schema in your applications. And the replication can BCP that data onto a different data center or a different cluster and do the same action by calling HCalLog client API. And then retention and archival can be applied, just as I said, which is really important. The last few considerations, if you have set up your infrastructure this way or have thought about setting up your infrastructure this way, is that it actually helps you with metering, audit, and governance. So the easiest way to audit the platform or implement an audit solution is to dist CP all your logs in a common place. And Hadoop has, in fact, every component in the ecosystem has a variety of system logs that are very helpful from all kinds of perspective, be it performance optimization, tuning, costing, metering, it doesn't matter. You could dist CP all that log into a common warehouse, which you could just build off of Hive. And we've done something similar, and we call that styling. But the idea there is that raw logs are cleansed and put in a table, and that table is understood. The schema is understood, and you query that warehouse, the Hive warehouse, for audits or for any other purpose, even debugging. Okay? Same solution can then be extended because now your data is registered in H catalog. You could create a global view of all the H catalog across multiple data centers into a common place and implement database classification for access control. Okay? So you have a very good handle on governance. And then every organization will have very specific needs. What we have done suits us. It's not a generic solution. But I think generic solutions are possible, but difficult, given the number of regulations we have around data. But a solution like this can be built and easy. And then finally, it works really well with almost all external systems. So if you look at our customers, pretty much everything Yahoo does is a customer. So all of that is a customer of Hadoop. And they work with Hadoop really well, be it through services we provide or bringing in their client-side applications and connect through Hadoop RPC or what we call as launcher boxes. All the other systems, a lot of these Tableau, MicroStrategy works seamlessly with Hive via Hive Server to ODBC, JDBC connection. So it's easy to connect your traditional BI tools directly to Hive instead of warehousing or creating a separate warehouse. And that works fine, as I said. Then on the serving side, you could have a variety of serving systems, and they integrate fairly well with Hadoop too. You can see a lot of infrastructure through the companies we've acquired recently are also in flight, so they're not completely transitioned over to the platform we manage, but that transition is easy because a lot of that infrastructure is also built on Hadoop or built on Hadoop, and as long as we have a common ground, it's really easy to move those over and consolidate all the companies' assets in a single infrastructure or platform. And then the same sort of philosophies can work for custom monitoring tools or any custom tool you might want to build on top, either to offer services to your customers or as a portal for your customers for information. Okay? And then, as I said, a lot of these things get talked about, and I don't really think they're issues. So I want to call those out. A lot of people think it's not ready. That's not true. We run our entire business on it. A lot of people say it's not stable, clusters keep going down. And again, a lot of that just happens when we do upgrades and mistakes. But so it depends on what you do. With all sorts of HA support across the entire stack and rolling upgrade support, I don't think that's true. The other common notion is that you may lose data on HDFS, yes, if you don't know what you're doing and delete data everywhere, yes, you will. But otherwise, I don't think we generally lose data on HDFS. And sharing is possible in a very secure fashion, as I just showed you. And name nodes, I told you already, scales fairly well. We have clusters with 5,500 servers on a single name node that is in HA mode. But just one name node can support it. It's not federated in any sense, the namespace. Software upgrades are rare. A lot of people think that platforms don't get upgraded frequently. I think we're upgraded every week or every other week. The core Hadoop stack, that's possible, and it's fine. If you have to meet your customer use cases and issues they've faced. Hadoop use cases are limited. Again, we've now seen things that we couldn't imagine before. Video transcoding is a good example. I mean, we never had people doing video transcoding on Hadoop infrastructure, and they're doing it now. So people are using Hadoop infrastructure in very different ways than we thought was possible. The other common notion is that you need to buy expensive servers. That's also not true. You can work your way and get performance out of cheap servers. Hadoop is not dead at all. In fact, it's emerging and growing real strong. We have seen tremendous growth in the use cases that are coming onto platform every single day. And then there's a lot of debate about Apache this versus Apache that. I don't think you can keep track of it given the rate of innovation in this space. So the best way to think about it is to just obsess with your use case and drive technology, which is actually gets driven by the use cases versus actually playing with technology and then fitting use cases to them. Okay. With that, I think I have a few minutes for questions. Yeah.
You mentioned network was a critical issue. Have you found, or can you comment, like on jumbo frames, certain kind of configuration changes besides architecture that you've seen performance increases on?
You mean in the traffic or?
Yeah. Hello? Is it turned on?
So I think I know what you're talking about. So under normal stress, most networks do fine because there is a lot of design consideration in the framework itself to prevent data sort of transfers over network. Most things are tried to be done locally. The places, but Hadoop, the way most big data applications behave is that these things create this thing called Incast, where large set of transfers happen towards sort of one destination. And those were the 3-4 scenarios I showed you. So you would hit them. And I think the idea there is that you want to construct a network that can take that. Because if you don't, then your platform sort of falls apart. That's probably the best comment I can make on that. And as I said, a lot of it is just a cost issue. How much do you want to invest in your network? What else? Yeah. Yeah. How do you manage the perception?
It's a big question.
I didn't hear it either. So.
Okay, so when designing an architecture, there was a use case of on-premise infrastructure versus on cloud.
Yeah.
I was missing the hybrid model where as I see it.
Yeah. Hybrid models are totally possible. We have a very large investment in our data centers, so we don't quite often think about a hybrid model. But a hybrid model may make total sense. And again, as you run your use case through those criteria, you may come up with a situation where certain things favor on-premise, certain things favor public cloud, and it's totally okay. In fact, a lot of people work that way, where you run certain things in Amazon and certain things on-premise.
How do you usually estimate total cost of ownership? Is there any framework for that, or on early stages when customers even don't know what exactly job will be or how many jobs will be?
Yeah. So I would do it as a back of the envelope type calculation in that situation. And then if you have a rough idea of the other elements, so for example, in our case, at that scale, I can make a safe assumption that hardware is just the hardware, is 60% of the rest of the cost. So 40% is everything else that I was showing. And then you can extrapolate that based on the cost of the server. So let's say, $5,000-$6,000 a server, $10,000 a server, and it lives for 3 years in your cluster or 5 years. You can just work your way that way. You don't have to calculate headcount and bandwidth and everything else separately. You can just take that split and do a back of the envelope calculation that way. That's a real easy way to do it. It won't be accurate, but it will be good enough to give you a directional sense for where your costs are. And then when you run the computations based on the usage, you could get a good picture of what makes sense and what doesn't make sense. It's really hard for me to comment on because it really depends on the situation. But if you follow what I showed and run those numbers yourself, you will get to a real good state. That is all I can say.
Okay, thank you. But I'm thinking maybe you have any internal guideline to make this process easier.
That's not an easy process, unfortunately.
Okay.
The back of the envelope thing I just mentioned is the easiest you can do. The other thing you could do is run a simulation on a public cloud and see what your bill was, and then extrapolate it based on how much scale you want. And then you can make slices out of that cost based on your situation, like, oh, it will be only 50% of this or 60% of this, based on how far you want to scale that. But doing a sensitivity like that, and if you are an Excel junkie, Excel has something called as data table. Data table lets you vary the 2 dimensions and give you results as a sensitivity analysis. That sensitivity analysis is what's more important than having a one number which drives your decisions. Because it'll give you, again, as I said, a directional sense for where things are. So you could have utilization on one hand, cost on one hand, vary utilization, and see how the cost plays out. Yeah.
Yes, one of your slides you were mentioning that old data was archived to tapes.
Yeah.
What's the requirement behind it? Because we probably never use it anymore.
So very business specific. So internet companies are required to archive certain things for a certain age, even though you don't need that data. So our assumption, archiving it on tape, is that we never have to restore it. Your business situation may be very different, where you have to archive on something where you periodically restore from, for a variety of reasons. So I can't comment on that. But again, comes down to cost, right? How much money do you want to sort of pour in your archival solution? We went with tape, or have gone with tape, because that is the cheapest solution. And no guarantees that you will ever be able to restore that data back. But we are required to archive certain set of data.
I think you have more than one data center.
Yeah.
Do you synchronize your cluster or the data centers, or have you more clusters spanned over more data centers, or how is the architecture?
So no, we don't synchronize clusters so the only synchronization is with replication of data. And not all data gets replicated one-to-one, so we don't mirror clusters. We mirror use cases. And that could be across a variety of data centers. And that is driven by the BCP requirements of the application. So applications design BCP. Platform provides the capability to design BCP solutions. And then the other sort of philosophy there is that clusters are graded as important and non-important. Well, I shouldn't say non-important, but experimental versus production, let's say, so to say. And production clusters are typically applications who run in production, typically BCP their data. But that is application specific. Your data lifecycle management tool should have capability for applications to design their own BCP solutions. And I think the simplest thing Hadoop does, which doesn't get talked about, is DistCP. DistCP is awesome. You can build wrappers around it and create all kinds of BCP solutions.
Okay, thanks.
How long does it take to replicate using DistCP in your environment?
In different colos, I have different link bandwidths. That's totally a function of the bandwidth and what else is happening. Most of our inter-regional links are shared. They're not dedicated for Hadoop. Other people use it too. So it totally depends on who else is using it at that time, as well as how much data are you copying. Really difficult question to answer without measuring it. So no guarantees there on particularly on inter-regional links or lease lines. One cannot, unless you dedicate the lease lines for Hadoop use cases, then you can guarantee performance of this CP transfers because you're controlling that bandwidth. We don't, it's all shared. And they're very expensive.
Last question, how many Hadoop administrators do you have now?
Our total ops headcount is about 20. 20, yeah. I think. May not be accurate. 22, I don't know. Close to that number. So I think we have the best headcount to server ratio in the industry when it comes to ops. I'm pretty sure. What else? All right, well, thank you very much.